Microsoft AI MVP. So I generally speak on cognitive services topics, but I do speak to data professionals. And I've found that AI has turned into this evolution of how we use data. And as data people, we're usually the people who get asked, you know, what are the possibilities, and how do we leverage data, and how do we leverage data responsibly, and how do we integrate, and what types of resources do we need? So I find that this is always a great group, because it's really, it's not that it's outside of our wheelhouse, it's just a different application of concepts that we regularly employ with a lot of the data engineering and data modeling projects that we work on. So I can go ahead and get started. And tonight, I'd actually like to talk to you about Cognitive Services Vision 101. So again, my name is Alicia Moniz. I author a blog, hybriddatalakes.com. I have my AWS and Azure certs. So I'm a Microsoft Certified Solution Expert. If that is a qualifying factor for you. I'm also an Azure architect as well as an AWS architect. So I'm currently working for Avanade as an architect, and I get to solution a lot of different data systems in the cloud for our clients. And can you see my screen? Did I click that button?
I don't think
Not
you're
yet?
sharing yet.
Okay, sorry. I'm excited. I'm so excited to be here tonight.
Also, just so you know,
And now can you
your webcam is like chopping you off at the eye level. There you go.
And
you can see
so
your
now can you
PowerPoint.
see my screen? Okay. Okay, there you go. And so Build is this week, and I'm very, very excited about Build as well. So I hope you're keeping an eye on some of the AI announcements that are out there. So let me go ahead and drop that there. Okay, so I thought I'd talk to you about a couple of different things. And I really put this deck together because the audience tends to be data professionals. And rather than going too far down a path that is only borderline interesting to you, what I'd like to do is I'd like to show you a number of different things, a number of different tools, introduce you to a couple of different principles that hopefully you haven't already been exposed to, so that you can take at least one new thing out of this talk. And if you're interested, you'll have enough information to kind of follow that down the trail on your own. So a good place for me to start is usually the AI demos page. So I'm not sure if you've already been here, but AI demos, and this is a web page that is hosted by Microsoft. This provides kind of an interface to the Cognitive Services APIs. So the Cognitive Services APIs are pre-packaged machine learning models that are hosted. They're built, trained, hosted by Microsoft on their compute. So really what you're doing is you're interacting with these APIs versus building from the ground up. And they have this web page that's available free of charge to interact with these APIs, so that you can see what the expected results are for a prediction against one of the data models. So we can go ahead and start with text. And I love this page because I do get asked a lot.
We're just seeing your PowerPoint.
Yep.
Sorry, my first I
think you're just sharing the program and not your window.
Yeah, can we try that one? And can you see the AI demos page? That's the PowerPoint. And then can
Yep.
you see my
Okay.
browser
Now
now?
your browser is popping up.
Okay, and thank you. So again, this is aidemos.microsoft.com. And basically, this is just going to be an interface that lets you interact with these cognitive services APIs that are up and running and readily available. And these APIs are a little newer. So I find that, people hear that I work with AI and I work with data. So I have a lot of people who don't work with data, who are interested, who want a little bit additional information. And this is an easy way for me to almost instantly delve into an environment where I can show them. And it constantly amazes me how many people out there they're thinking that AI is robots. And then on top of that, they're thinking, well, this is future tech and this isn't current tech. And once you look at what the tech is actually doing, you realize that, yes, people are already using it. And you get to know kind of the prevalence of it throughout organizations today. So working in Houston, I do work with a lot of the oil and gas, and I do get to see a lot of the cool Internet of Things projects coming out and the machine learning on edge devices that we work with clients on. And like, you really realize that, and this tech is now. And if you're not using it, you will be using it fairly quickly. So it's really to a lot of our advantages as data people to at least be aware what the capabilities are so that we can position ourselves to kind of pick our spots on those teams when they start building these teams to support some of these strategic projects, right? So anyway, we can go ahead and click on text analytics. And I'm going to enter in here, my family lives Hawaii, because we really do. And I'm from Hawaii, just in case you couldn't tell. And we noticed that this is a very common application of AI on text. We've got this sentiment analysis here for 84%. We've also called out this key phrase. And then we can skip down to entity linking. And when we click on Hawaii, it's able to decipher that Hawaii is actually the state of Hawaii and sends us over to the Wikipedia page. So this is a bit of a fun fact, but the Wikipedia content is freely available and has been used as a source for training models for Microsoft. So this is an example of supervised learning, where you take a data set, a known data set, and you're able to work with it to provide an expected outcome with a certain degree of confidence. And so this is why they're able to make these machine learning modules publicly available, because the data's already been curated and tested for a certain percentage of confidence. So this is great for us as developers or as data people, where we don't spend as much time doing the actual data science tasks, but now we're able to leverage some of these features and some of these benefits by simply making these API calls. So let's take a look at what Vision can do for us. So the 4 core functionalities of Vision is It'll let you analyze and describe images. So we've got an image up here with a building and some water in it. And we're able to pull out some tags with a certain degree of confidence. So 100% that there's a tree, 99% confidence that it's outdoors. There's a couple of more tags down here. And then you see that there's actually a descriptive sentence that relates to the tag. And this really kind of brings to the forefront how Microsoft is interweaving the capabilities. So as you use the different services, you'll notice that there's overlap between the text and the language and the vision APIs, so that the APIs are enhancing the types of information and analysis that they're providing for each other. So another thing to note is the racy and adult content tags. And this really highlights the importance that people are placing on ethics and the use of machine learning to kind of do some of that filtering for us, right? So a lot of these applications for AI nowadays are for tagging and metadata assignment, and it's really that labeling and classification. So if we can automate that 80% and do some preliminary actioning or steps and get things from phase 1 to phase 2, then that really leaves us with a smaller subset of data to action against as human beings. And I think that's where you're going to get the most kind of value out of your machine learning systems, is finding something where that 80% is redundant and automating or auto-categorizing that first step, and then leaving that smaller chunk for people to process manually. So another capability of computer vision is being able to read text and imagery. So we can go ahead and select this image, and there's a big number 42 here and a small number 42, and we're able to pull out the word straight. We can go ahead and pull handwriting out of text, out of imagery, and then this is actually OCR functionality, but there's a new functionality that was just released last year where you can actually pull out handwriting from forms, and that's pretty neat. And then the last functionality that the computer vision is capable of is recognizing celebrities and landmarks. So we can go ahead and there's 100% confidence that this is Satya, but again, this is supervised learning. So if they have control over the data set, they were able to upload X many pictures of him, and maybe this was one of the pictures in the training data set even, and that's why that confidence level is so high. So when we look at that supervised learning, that's why this says recognize celebrities and landmarks and not recognize Alicia in Houston, because chances are my picture was not included in that set of celebrity images that they use to build this data model. So that's a high-level overview of some of the computer vision functionality and where you can go to interact and play around with it. Now, the Cognitive Services Vision suite is composed of the Computer Vision API and the Custom Vision API. So we went over the Computer Vision API, and we saw that there's a fair amount of information that we can extract from general and common items. So the question is, what if I have images that are not common Or what if I have a more detailed or specific use case where I'm trying to decipher or make binary determinations based on images. And that's where we can leverage the Custom Vision API. So the Custom Vision API is going to allow us to upload images, perform our training, and tweak our evaluation so that we can determine what our tolerance level is for false positives and true negatives. So there's also capabilities in the API to perform object detection, where the API will actually return the bounding boxes of the objects within the image. So some of these applications are, companies are using drones to perform work previously performed by people. So there's a lot of maintenance type of activities or monitoring type activities where work sites that are placed far apart. There's actually a lot of savings in having a drone fly over the site and send back pictures where you can use object detection to determine, hey, is the field gate open, or is the barn door open, or is the machinery still running, or is it in stop state? And then you can go ahead and use that as a triggering / alerting mechanism to go ahead and trigger that mechanic or that repair person to go out into the field to perform the work required, versus having somebody make routine checks throughout the week where, you know, statistically, what is the chance of them being on site when an event occurs?
Can I ask you a question?
Absolutely.
Do you
Hi,
have
Jeremiah.
a sense? Hi, Elise. Alicia, nice to meet you.
Good to meet you.
Do you have a sense as to the minimum sort of number of images in a at least moderately realistic scenario that you could expect to need to train
20.
a model? I know to do super complicated stuff like to tell if somebody has the flu or something, you'd need billions, but like
you need
do,
20.
you
Yes.
can, so there are some models that you can train with as few as 20 images.
Today we are going to build a model with 20 images for yes and 20 images for no. And you're kind of spoiling the punchline, right? But that's what's so exciting about these services and what, you know, machine learning can do for us, right? Because, you know, rather than having to know how to build a machine learning module and how to code it, these services kind of abstract all of that for us, where we can generate a reasonably performing module with 20 images, and that's what we're going to do tonight. It's pretty exciting, so I'm excited. So our use case tonight, and this is a good segue, is so I just moved to Houston, and I moved from Las Vegas, where it never rains, to Houston, and I arrived right after Hurricane Harvey. And you look at our infrastructure and you look at our weather alerting systems, and there still was all this devastation, right? So, you know, I started thinking of, well, how much data do you think a weather reporting system needs? And so you have wind, you have temperature, there's all kinds of things that they keep track of, and I kind of still feel like they get a lot of it wrong, right? So how do we simplify this problem? So one of the things I've been playing around with is flood detection alerting. So when you look at the infrastructure that cities currently have in place, many of the water districts already have these video cameras that sit on top of critical waterways, just to kind of to track that the waterways are clear. And so I questioned, you know, so the hardware is already there. They're already storing the data, you know. Can we provide more real-time alerting of some of these situations without that huge programming impact of kind of rebuilding a national weather system? So what we're going to do today is we're going to go ahead and build a custom vision model. And I took 20 images from this video of the water in a flooded state, and then 20 images from when the water was less than halfway up. And I'm going to use that to build my identifier, where I can visually alert myself as far as, is the waterway in flooded or not flooded state. So I can go to my notebook, and I'm not sure if anybody's been in Azure Notebooks before. And Azure Notebooks is the Azure flavor of Jupyter Notebooks, and the compiler runs on Azure Compute. So this is a handy, again, another, I'm all for easy ways to get to my code. So a lot of the times I'll just go ahead and jump on somebody else's computer and pop open my projects. I don't have to worry about installing Python or installing the right Python library, or making sure that, you know, I'm not installing a library on top of an existing library. And actually, I'm skipping ahead. Sorry about that. Sorry, we're actually going to start in custom vision first. So I get to do a lot of, you know, fun stuff with pictures. So that's my dog. So I did do a puppy finding project recently. So that's what that is. So I'm in the custom vision.ai kind of directory. And again, this is kind of that interface that lets you deal with a lot of the calls that are exposed by the cognitive services APIs. So I can also create my cognitive services service in the portal, but this is that UI that lets me work with all the function calls within that API in a user-friendly interface. So I can call this flood alerting. And I've already created my resource. And if you haven't used the cognitive services resources before, there is a free tier. So they make it very, very easy for you to jump in and start playing around things. And there's actually quite a few predictions that you can get out of your project at the free tier. So right now I'm just doing a binary classification. If I wanted to, I could do object detection, but I'm not trying to identify boats on the waterway. I basically have a binary true false case. So that's why I'm going to stick with just classification for this project. Single tag, again, it's very simple, just one case, yes or no. Now the domains here are, because this is supervised learning and because your data, like your outcome is as good as the data that's, you know, underneath the data model. So there are a few very specific use cases that Microsoft they've curated the data and they've designed a solution that's specific to a certain use case. And that's what these domains are. So I'm not sure if you've seen the solution where they're able to identify when there's empty shelves in the grocery store. But that's definitely probably one of the projects that drove the creation of the food domain. And then we were playing around with the celebrities and landmarks. And again, there's a finite set of landmarks, either in a geographical location or throughout the world. So when you're looking at curating that data and guaranteeing that expected outcome, it's a lot easier to do that than to take pictures of a field and expect to identify every cornfield in Omaha or something. And I love Omaha. My in-laws are from Omaha, so no offense to Omaha, but there are a lot of flat rolling fields there. So I think that would be a hard task to complete. So we can go ahead, and now we've got our project, which is our container. I can go ahead and add images. So I have my 20 images of my flooded state here. I'm going to tag them as flood and upload. I also have my cases for not flooded. I'm just calling them okay. I can do a quick train on my images. It's usually just a little bit faster than this. Builds going on this week, so there's probably some mad analysis going on up there. And again, this is the free tier. So it is usually way faster than this with just 20 images. And but you can see that there wasn't any coding from my side. I didn't have to do any math. I barely put any time into it. And after this processes, we'll see that I'm able to get fairly accurate results from the images that I test against, with just 20 images in each case. So that's comparative to, you know, how we're doing things programmatically. So machine learning is really going to enable us to train by example. So with images, we're providing examples of a case. And the model is able to extract enough commonalities between our examples where it's able to decipher that on its own. Whereas if we were coding something up, we would have to provide the expected outcome for each case, right? So that's if case statements, well, if statements, case statements, all these evaluative statements where we would have to iterate through all the possible cases. And at the end of the day, you probably can account for 80% of the cases, but there's still going to be those one or two cases that you didn't really think all the way through on and ends up making it as an application bug, right? So that's really one of the advantages of these tools is just the ease in training the systems using examples versus programmatically. So this is still going. Can we, okay. So we can take a little bit of time to look at the project settings. So this is my information in my Azure subscription. We have a key and an endpoint, and this is how we're going to programmatically interact with our cognitive service. So we've built our model, we've provided the images, we've trained it, and now we have an expected outcome. So how do I communicate with that model? And I'm gonna go ahead and programmatically pass my key and my endpoint. And I am going to look for my wiki page that I had up. So this is the computer vision API definition. So
For screen sharing stuff.
thank you. Okay, am I back?
Yep.
Okay. Okay, so the API page is really going to be kind of your dictionary into how do you interact with the API. You can go ahead and select the region that you're in, and it'll pop up a testing console for you. You'll notice that the API is not available in all regions. Usually they'll go ahead and upload the AI APIs in the most frequently used regions. And it's because these are resources that are hosted and maintained by Microsoft on Microsoft's compute, and then you're just referencing what's on them. So you'll have a request URL with your endpoint. This is where I would put my endpoint. There's an example of parameter types. We've got my subscription key here that it's expecting. The request body is going to be either the image contents in binary or the URL for the image. And the APIs will actually include code examples here in multiple languages. So again, they make it very, very easy to interact with all the APIs. And I usually pull the Python strings out of here. So I think that's 2.7 at top, and then I'll be using 3.2 a little later. Now the expected response is going to be a JSON string. So you will usually get back this is what we're passing. And because there are APIs, most of the time you don't have to pass more than 3 or 4 arguments. So again, very, very easy to programmatically interact with these APIs. So let's see if this has stopped running. And it looks like it's still going. 6:31. Training underway. Okay, well, in the interest of time, I could probably show you the result of an existing project so that you don't have to wait for that to complete. It usually runs in 10 to 15 seconds. So I'm not sure why that's taking so long. And so this is my daughter's dog. And it's important to note that I received permission from my daughter to use these images of her stuffies as well as her dog. And it's kind of interesting to see how important that permission is going to be as we start using these technologies moving forward. You know, like if you're applying this technology at work, from all the employees to take pictures of their faces or at different employee events, and what is the expectation for privacy? And it's because these projects require so much data that we are collecting so much data that's why these questions are becoming so much more important, because there's so much more personally identifiable information of ours that's spread out amongst all the companies that we do work with, that, you know, you can conceivably reconstruct my history, my data history, if you went to all the public places that posted my data and reconstructed it. So responsible ML is a big topic at Build this year, and it's just amazing some of the tools that they're making publicly available, so that you don't have to be a data scientist and you don't have to have teams of data scientists at your organization to start being the data steward that, you know, we all should be when we're touching and interacting with this much data. So again, this is 15 images here and 20 images here. And my test was puppies and stuffies. That's what my daughter calls them. And let's see if I have a stuffy. My daughter's 7, so she tolerates me. She says I work too much. So we have some bounding boxes here, and you see that our prediction is fairly low. And why is that? Now, there's a lot of things that affect with vision, the accuracy of our projects. So there's relevance. So if you're trying to predict images of broken machinery in the field, are you using brand new machinery that's still in the factory, that's shiny, bright, and new with no dirt anywhere to build your model? So these are some of the questions that you need to ask yourself when you're building. And then you also want to include a lot of variety. So I always laugh when people, you know, talk about locking their phones with their faces, because my face changes pretty frequently throughout the year. And if you think about the amount of variations to your face, you would have to hold the camera almost exactly the same place every time. And then if you had a beard, would you worry about not being able to unlock your phone if you shaved your beard, right? So when you're working with these models, sure, I can, you know, build a model that will classify with 20 images, but will it be correct all the time? And does it handle every case, right? So with 20 images, I could probably, with the camera in the same position every single time, probably get a yes or no, is that Alicia? But if I wanted to have real time where I'm taking video from in front of my door or monitoring, you know, for intruders, where sometimes the frame is a little blurred because it's in motion, or you have a different angle of my face, then if I wanted to account for all of those cases, then what I really need to do is I need to feed more images into my data model. So use cases that and light. So light absolutely will affect the accuracy of the prediction. And this is a pretty low light image, so I think light is probably going to be the biggest factor as far as how low that prediction rating is. So Jeremiah, did that kind of sort of answer your question just a little bit?
That was fantastic. Thank you.
Okay. But
So
like
my my training my model to recognize your face during the call is probably not going to work, is what you're saying.
well, I do move around a lot when I talk, so you know, but it's intentional, so you can't recognize me, right? No, I'm just joking. So you can actually create. So I'm on the SO tier, but you can create 2 models, 2 projects on the free tier. You can see here that, so these are the number of predictions that I have left. So you can do 100,000 images uploaded. I've created 2 out of 500 tags. So when we talk about like the food domain and how many fruits there are and how many vegetables there are, with 500 tags, you could get some pretty good predictions out of the project, right? So with respect to privacy, there's a couple of things that get factored into privacy. So you can run cognitive services on containers. So if your concern is sending images up to the cloud, then that helps with that. And there are some APIs, and one of them is the face, which we're going to get into very shortly, where they don't actually keep the image when they're doing the analysis. They'll perform the analysis, but not keep the image with the service. So we can go ahead, and now I can jump into my Jupyter notebook. And this is directly out of the face API documentation. So just to give us an idea of what the capabilities are, so this is a custom vision model that they've trained specifically off of, you know, the identifying landmarks of people's faces. So that's a 27-point face landmark. Some of the attributes that it lets you look for is age. Though I don't know how accurate that is. But I think it's as accurate as a human eye is, right? Male or female, smile from 0 to 1, facial hair, head pose, glasses, emotion, accessories, and one of the questions that, you know, I tried to answer with this was, and they actually had this on display in Redmond at the Microsoft buildings for a while, and it was providing that age guessing. And I kept laughing because, you know, if I smiled, my wrinkles would show and my age would be in a high range. But if I made no emotion on my face and no wrinkles, then, you know, I actually got it all the way down to like 23 or something. And of course I felt great, right? But I started thinking about, you know, well, what are some of the things that you do to make sure that you get that true positive? And one of the questions that, or use cases that we were contemplating is, you know, with gender recognition. like, how accurate is that? So in addition to pulling the gender attribute out, I actually decided to pull out facial hair because I figured that would be a good second kind of attribute to check against my initial attribute and kind of see if they correlated. So I do have a picture here, and I can go ahead and back out and pull that up. And I think I just want to do preview. Oh, it crops really weird. But this is a picture of me and 3 other speakers. And it just prints funny via the UI. And I'm gonna go ahead and pass over. So this is my API that I've created within the portal, within my subscription. So it's metering my predictions. And then the request is returning back these attributes. So beard, mustache, sideburn, and when male. Beard, mustache, sideburn, and one other male. No beard, mustache, and sideburn, and that was me. So the first time I ran this, I was quite interested to see, you know, if my mustache would show up because, you know, sometimes it's pretty prominent. And so thankfully, the facial recognition software did not detect. And then we've got one more male in the image. But it's kind of interesting because it really does kind of highlight the responsibility that goes into building these systems and the amount of checks that as developers we should kind of think forward to, and the importance of us having a balanced data set, right? Because again, data in and out, they're totally related. So if the quality of your data going into the system isn't where it needs to be, then that will absolutely affect the outcome of your data, right?
Well, I remember there was like a couple of years ago, there was this big news thing about I don't remember what company it was, had built this big AI tool that had done text recognition and it could like have a conversation with you. And after a few months of training itself, like it got to the point where basically all it did was make racial slurs. And it was like totally discriminatory, this whole thing, this little AI module. And it was this, I don't know. Do you know,
Yeah.
like with facial recognition, that's what immediately came to mind. It's like, does it automatically, like, does it have some way of, you know, managing that?
So it's kind of the frequency, right, of the data. Like and so more recently, there was a bot. I want to say that it was, and I don't video game, right? So it was one of the video game systems where they created a bot to play the game and interact with people, and within a day, it just obscenities and trash talking, and you know, the quantity and the variety, and like that will drive the evolution, right? So
So don't train your data set on gamers is what you're saying?
hey, I don't judge. I went to school with a lot of gamers. I drink with a lot of people who are in networking. So, you know, we need them to keep the lights on, right? So I do not judge, and I'm a data guy, so I also drink a lot. But you know, it's supervised learning, and it's, well, what types of data and data elements are you exposing to the data model, right? And then that is what it's learning, and that is what it's going to cater towards. Now, with respect to language and text, a lot of these learnings are regional. So some of the services are only offered in a couple of languages, right? Because words mean different things in different languages in different regions, right? And they want you to have a fairly consistent experience and have a fairly consistent expectation far as results if you're leveraging one of these tools for your business application, right? So like if you're using it for transcription or, you know, encoding, a lot of this has to do with metadata tagging and data labeling, right? So yeah, definitely regionality has a lot of influence on that as well. So that was kind of a run through of vision capabilities. So we went through the computer vision, which is the pre-packaged machine learning module that's already built and available for you to interact with. And then we went over the use case scenario of the computer vision module, which is, hey, I have a specific case and I have my own training data, and I'd like to teach the model to do something specific, and I want to be able to contribute to the outcome as well as the training. And we also went over the Azure Notebooks and a little bit about the AI demos. So I hope that there was something here tonight that you haven't seen before, and I hope that you've taken something away from tonight that you can share with somebody else. And again, I'm a very, very strong advocate of PASS. So strongly encourage you to continue participation in PASS activities. And thank you for having me tonight. I appreciate it.
Can I ask another question?
Absolutely.
So my first question was about how many images on average does it take to train a simple model?
Mm-hmm.
In terms of like learning curve and learning to get to the point where you know how all this stuff works and how to train a model, and let's just say my example was like I wanted to put a video camera on top of my door, and I wanted to tell whether the person coming up to my door and knocking on it was my dad or a Mormon missionary or
Mm-hmm.
my daughter or a stranger, like somebody else.
Mm-hmm.
Like how long, and let's say I just had all the images, how long would it take for me to learn how to do it, train the model, and get something that I could actually apply to my video camera above my door? So like when
Yeah.
somebody comes to my door, it'll
Well,
tell me, hey, there's Mormon missionaries at the door.
Well, I think you'd want to deconstruct the problem and
Mm-hmm.
look at it's supervised learning. So what do you have versus what do you not have, and test for what you have examples of, right? So what I would do is I would take pictures of your dad and take pictures of your daughter, and then code for cases that are not your dad and not your daughter, right? And then that would account for everybody else. Now, if you said you wanted to decipher between, you know, salespeople and your mailman, and you don't have a designated mail person and you have different mail people, then that would be fairly tricky. I would, then you would have to like defer to either a uniform or, you know, the mail truck, but something unique that would lessen the amount
Right. Like I was thinking like,
of
you know, Mormon
examples.
missionaries have a uniform they wear. They always wear the same clothes.
But then you would have probably a false negative if somebody wasn't, right?
Sure. Yeah. If you
Yeah.
had, they could beat my model if they really wanted to, and they could
Yes.
sneak up to my door and convert me.
Yes. It could be a cold day and they'd be wearing a jacket and you wouldn't see the white shirt, right?
Well,
So
you
like, how
could.
long would it take for me to learn how to do that so I could build it? Like,
Yeah.
if I
Well,
was starting from scratch.
how long did it take me to do what I just did?
Right.
Right?
I know you did it, but you've been using it. Like,
Yeah.
so like for you to learn how to do it and like
So
start from the start.
I challenge you, sir. It's collect 20 images of each case and sign into customvision.ai. If you have any issues, you can send me a shout out on the Twitter and we'll get you going. But there's no reason why you can't have a model up and built in under an hour.
Oh.
It's, you
Yeah.
know,
So
now
the
you can
the
play
thing
around
that
with
I
the
was,
accuracy, right?
yeah.
But yeah, you can get you can dip your toe in the AI water in an hour.
Nice.
Yeah. And I think what it would be is trying to think yourself about what you want to identify. And so one of the things that I thought about was identifying an employee ID badge as someone walks in. And so you could use that. And so the Mormon missionaries generally wear the same sort of badge. So you could use it to do text recognition on the badge of the missionary to kind of just say, if it says this, then clearly it's a Mormon missionary or something like that. So you kind
But
of have to look for.
so, but you know, do you? I guess on your property it would be one thing, but
Yeah.
you know, is it responsible of you to do that to people on the street, right? So,
Right. I used to do video surveillance for airports, and the big question was, like, are you going to look for terrorists, or like when you walk away from the terminal, you're not supposed to turn around and go back. Is it appropriate to look at people and determine whether they're turned around, not trying to identify who they are? And like they decided it was okay to tell if somebody was turned around, but it wasn't okay to try to detect who they were.
Okay. Well, you know, somebody tried to do automated facial boarding, right? And then there's also those cases where there are schools who were using, you know, facial recognition to admit students. And, you know, your image to a certain degree belongs to you, and you should have some say about, you know, where your image is stored. And you know, there's GDPR, and I think that we're going to get more concerned about it because of these new technologies that can piece our faces together and, you know, seamlessly embed our images in video, you know. So I think we are going to have to start caring a little bit more about where our collateral is, right?
Yeah.
Cool.
Yeah. So
Well,
I'm Alicia Moniz on Twitter. So I'll be expecting your tweet at 11 in the morning tomorrow, and you should have a fully functional model by then, I think.
Well, it's going to take me a little while to get enough Mormon missionaries visiting me that I can train it. It's probably just going to take a little while.
You just call the number for a free Book of Mormon and they'll definitely visit you.
Yeah, I think I found this thing and I'm kind of curious, you know.